Securing a top-tier remote engineering or data science role requires passing a gatekeeper, but today, that gatekeeper is rarely a human hiring manager. It is an automated, deep probe AI assessment platform, like Micro. The interview begins with a technical prompt. How would you resolve high latency in a production database? You might sit up straight and look into the webcam, but the AI ignores your posture. It strips away your visual humanity, converting your response into a live, scrolling matrix of pure text data. Candidates step into these interviews unprepared for how literally the software evaluates that text. They expect a casual conversation. Instead, they face a system that grades the mathematical density of their vocabulary. Surviving this system requires abandoning standard interview advice. You have to reverse engineer the AI's processing pipeline and learn exactly how it parses your logic. Senior engineers often approach an AI interview assuming it operates as a static, surface-level keyword scan. They list off software tools, expecting the system to simply check boxes on a digital rubric. The reality is a highly aggressive cross-examination. In a traditional interview, a human hiring manager frequently nods past a vague technical explanation to maintain rapport and avoid social awkwardness. A machine lacks social programming. It actively tests the boundaries of your competence by dynamically generating follow-up questions based on your specific answers, pushing until your logic breaks. We are going to dismantle the 3 grading mechanics that drive this interrogation: semantic density, voice activity constraints, and chain of thought parsing. Misunderstanding this platform as a simple digital test is why mathematically flawless candidates still fail the assessment. The first filter your answer hits in the processing pipeline is semantic density. The system evaluates transcribed text by acting like a digital sieve, separating technical signal from conversational mud. The mud consists of filler words, personal emotions, and vague adjectives. Phrases like super annoying or I feel like provide zero structural data. The system discards them immediately. The AI hunts for precise technical nouns, permanently coupled with specific action verbs. It highlights rely on automated tracking, flag conditions, and reduce holding costs. A candidate who says, I manage the warehouse stuff, generates almost zero signal. A candidate who says, I deploy automated tracking to reduce holding costs, delivers high semantic density. The algorithm requires these strong verbs to mathematically map your actual responsibility over a system. Without the verb, the system cannot verify you actually performed the work. Maximizing semantic density is the only method to prove functional competence to a data-hungry language model. Adaptive branching logic uses your transcribed vocabulary to construct a targeted interrogation. The system does not pull from a fixed question bank. It generates the next prompt based entirely on the semantic data you provided in your previous answer. If a candidate mentions eventual consistency to sound impressive, the node recognizes the term and instantly spawns 3 highly complex child nodes. The AI locks onto that specific term, demanding a measurable, real-world result of implementing that strategy during a peak traffic event. The cascade creates an infinite tunnel of interrogation. This tunnel is engineered to corner candidates who exaggerate their experience. If you list a tool on your resume, the system will force you to explain its underlying logic. The system expands deeper into each topic until the candidate either provides a flawless technical breakdown or reverts to vague, non-technical language. You cannot bluff an adaptive logic tree. It uses your own vocabulary to dig a hole until your expertise collapses. Beyond the text parser, candidates must navigate voice activity detection, or VAD. When humans encounter complex math or deep architectural problems, our instinct is to break eye contact, stare at the ceiling, and think in complete silence. That instinct is fatal. To an automated VAD system, continuous silence is mathematically equivalent to the candidate ending their answer. If you sit quietly to calculate a variable, the AI will abruptly cut off the microphone, log your response as finished, and advance to the next prompt. You lose the chance to answer. You must utilize a technical countermeasure called speak-to-pause or meta-narration. Instead of thinking quietly, you verbalize your mental task. You state, I am taking a moment to review the constraints of this equation before calculating the array. Continuously feeding audio to the VAD keeps the microphone active, but it also demonstrates a highly organized, methodical approach to troubleshooting. The final layer of grading is chain of thought parsing. We can see this in the ultimate stress test, calculating the probability of getting exactly 50 heads in 100 coin tosses. A common reaction is to panic and attempt to calculate 100 factorial mentally. Attempting the raw math is a trap. Calculating 100 factorial naively in a standard program causes a catastrophic integer overflow error. The memory allocation spins out of control and fails. The AI is testing if you understand this architectural limit. It is looking for the candidate to avoid the raw calculation entirely. The correct execution is to verbally acknowledge the integer overflow constraint and propose the safe engineering workaround, the normal approximation. The chain of thought parser grades this by scanning for the structural bridge words in your transcript. Because the trials are large, therefore we avoid the overflow, assuming standard distribution. Jumping straight to a numerical answer without narrating these syntactical joints creates a logic gap. The machine grades the transparency of your reasoning, not just the output. Zooming out from the code examples, the macro result of a 40-minute AI interview looks like this: a flawlessly connected, glowing web of verified logic. Contrast that with a broken, fragmented web. That is the visualization of a candidate who rambled, fell into the silence trap, or relied on buzzwords. The platform functions as a real-time stress test of architectural judgment, probing for the reasoning behind a choice rather than the facts found in documentation. Surviving the deep probe requires stripping away vague corporate language entirely. You must rely on undeniable logical sequencing. The AI demands a level of structural transparency that traditional human interviews rarely enforce. Social politeness covers logic gaps. Algorithms expose them. Preparing for this environment feels rigid. Speaking in structured blocks with constant meta-narration is an exhaustingly mechanical process. Engineers are now forcing themselves into a mode of strict mechanical logic, purely to satisfy the requirements of the algorithm. By submitting to that structure, candidates actively eliminate their own conversational flaws. They drop the filler, articulate hidden assumptions, and connect their thoughts clearly. Adapting to the machine's constraints requires you to eliminate logic gaps and connect scattered thoughts. The same precision required to satisfy an algorithm ultimately produces a sharper, more